In this lesson, we're going to be reflecting over other vertical and horizontal lines. In our last lesson, we reflected points and shapes over just the x and the y axis. But there are many other horizontal and vertical lines that are on the coordinate plane. And in this lesson, we're going to see how we can reflect over those different lines. Before we do that, though, we're going to look at characteristics of vertical and horizontal lines. In our first example, a vertical line is shown graphed below. 4 points were plotted on the line. What we're going to do is write the coordinates of the 4 points. So we're going to start with point A. Point A is located right here. And if I go from the origin and count over to the right, I have to go 4 units to the right. And then I have to count up 8 units, meaning that point A is at 4, 8. Point B is right here. All right, point B's coordinates from the origin, I would move 4 units to the right, and then I would have to move 5 units up, so point B is at 4, 5. Point C is right here, which is 4 units to the right of the origin, which is at 4, 0. So point C is actually on the x-axis. And then we have point D, whose coordinates we need. Point D is right here. So again, I'm going to go 4 units to the right, and then I'm going to go down 3 units, meaning that point D is at 4, 3. All right, question B asks, what is common among the 4 points? Well, if you look at the coordinates of the 4 points, notice that all 4 points have this exact same y or x coordinate. They all have an x coordinate of 4. All right, so I can say that the x coordinate is the same for each point. Okay, and that's actually going to be true for any point along that line. All right, so this point right here is at 4, 1. This point is 4, 2, 4, 3, 4, -1, 4, -2. Any point that's along this line has an x coordinate of 4. And since every point has an x coordinate of 4 on this line, what equation could we use to represent this vertical line? Well, this vertical line would be the equation x equals 4, since every point has an x coordinate of 4. So I can actually label that on my line just like this, x equals 4. In example number 2, a horizontal line is shown graphed below. 4 points were plotted on this line. Once again, we're going to write the coordinates of the 4 points. So we need point A, point B, point C, and point D. Okay, and if we look at point A is right here, so I have to go to the left of the origin 4 units, and then up 7 units, so it's going to be located at -4, 7. Point B is found right here, straight up 7 units from the origin, 0, 7, meaning that point B is on the y-axis. Point C is located right here, so I'm going to go 2 units to the right of the origin, and then up 7 units, 2, 7. And then point D is found right here, so from the origin, I'm going to move 6 units to the right, and then up 7, 6, 7. What is common among these 4 points? Okay, well, if you look at these 4 points, notice that they all have the same y coordinate this time. Okay, the y coordinate is the same for each point. Okay, well, if I look at my 4 coordinates here, all right, they all have the same y coordinates. The y coordinate is 7. That is going to be the equation of this horizontal line. All right, since all of the y coordinates are 7 along this point, y equals 7. So you could go to -1, 7, -2, 7, -3, 7, or you could go to 3, 7, 4, 7, 5, 7. Every point along this line has a y coordinate of 7, so its equation is y equals 7. All right, and that leads us to, on the next page, all right, Horizontal and vertical lines. Horizontal lines are parallel to the x-axis and will always have an equation in the form of y equals some constant. Okay, but if it's a vertical line, vertical lines are parallel to the y-axis and will always have an equation of x equals a constant. So if your equation starts out x equals, you know it's a vertical line. If it starts out as y equals, it's going to be a horizontal line. In our next example, we're going to graph and label the following lines. All right, let's start with x equals 4. All right, if the equation is x equals 4, that means that every x coordinate along that line is going to have an x value of 4. So we could say that 4, 0, every x coordinate is 4. We could say that 4, 0 is a point on the line. We could say that 4, 1 is a point on the line. We could say that 4, 2 is a point on the line. 4, -1, 4, -2. Those are all points that are on that line. So 4, 0 is going to be found right here. 4, 1, 4, 2, all right. 4, -1, 4, -2. All of those points are on that line, so we can go ahead and graph that line. All right, it's going to look something like this right here. All right, this is the line x equals 4. So we'll put an arrow on each end here, and we will label it as x equals 4. All right, in question B, x equals -5. So this time we could have -5, 0. We could have -5, 1. We could have -5, 2. All right, we could have -5, -1. We could have -5, -2 as points on the line. And so if we go ahead and graph those, -5, 0, -5, 1, -5, 2, -5, -1, -5, -2. These are all of the points that lie on that line. And so if we connect them, any point on this line has an x value of -5. And so I put my arrowheads on there, and I can label this as x equals -5. All right, what about if it's y equals 3? So this time every y coordinate will be 3. So we could have 0, 3. We could have 1, 3. We could have 2, 3. We could have -1, 3. We could have -2, 3. Every y coordinate is a 3. So 0, 3 is found right here. 1, 3, 2, 3, -1, 3, -2, 3. Every point on that line has a y value equal to 3. And so we connect those. And again, we'll put arrowheads on there. And this is the line y equals 3. Every y coordinate has a value of 3. If y was equal to -7, so we'd have 0, -7, 1, -7, 2, -7. We could have -1, -7, -2, -7. As long as the y coordinate is a -7, the point will be on that line. So if we have 0, -7, that's going to be 7 units down from the origin right here. And there's 1, -7, 2, -7, -1, -7, -2, -7. Connect all of those points along this line. That is the line y equals -7. So put your arrowheads on it and go ahead and label it. That's the line y equals -7. In our next example, 4 lines were graphed and labeled below. Write the equation of each line. Plot 2 or 3 points on each line and state their coordinates to help determine the equation. So let's find line A. All right, here's line A, and we'll plot a couple of points that are on line A. I notice that this point right here is on line A, and that has coordinates of 7, 0. All right, another point on that line is right here. All right, and that point is at 7, 4. Another point on that line is right here, and that's the point 7, -2. Notice that every point on this line has an x coordinate of 7, So the equation of that line is x equals 7. Let me clean that up. X is equal to 7. So let's go ahead and label that. X equals 7. All right. In line B, which I see right here, well, I see this point is on line B. That's the point 0, 6. And I see this point up here. That's the point, oh, excuse me, I missed. Erase that. I need to be on line B. This point is on line B, so I went to the right 3 and up 6, so that's 3, 6. All right, this point is on line B, that's 5 to the left and up 6, negative 5, 6. Notice all the y coordinates have a value of 6, so this is the equation y equals 6. Line B, y equals 6. Line C, found right here. Once again, we can plot some points that are on it. And again, I saw that this point was on it. That was the point negative 5, 6. All right, I can plot this point right here. That's negative 5, 0. And I'll plot one more point, maybe this point way down here. All right, that's the point negative 5, negative 9. Every point on this graph has an x-coordinate of negative 5, so the equation is x equals negative 5. So let's go ahead and label that. This is the line x equals negative 5. And then line D, right here. All right, line D. So this point is on line D. That's 0, negative 4. All right, this point is on line D. That's 5, negative 4. And this point is also on line D. That's negative 3, negative 4. Every y coordinate is a negative 4, so that's the equation y equals negative 4. Y equals negative 4 is the equation of that line. In example 5, we're told that triangle ABC has the following coordinates. A is at 8, 3, so let's go ahead and plot that. 8 units to the right and 3 up, there's point A. Point B is at 7, 7, 7 units to the right and 7 up. Right there's point B. And then point C is at 9, 6, so 9 units to the right and 6 units up. Right there is point C. All right, we've graphed it, we've labeled it. Let's connect our points, and it will look something like this. All right, there's our triangle ABC. Now, what they want us to do with that triangle is graph triangle A prime, B prime, C prime, which will be triangle ABC after a reflection over the line x equals 1. Okay, so we're going to reflect triangle ABC over the line x equals 1. All right, any equation that starts out with x equals is a vertical line. Okay, and what we're going to do is go ahead and graph that line so that we can see the line of reflection. So if we find the line x equals 1, well, it's this vertical line that's 1 unit to the right of the y-axis. This line right here. That is your line of reflection in this example. So what we're going to have to do is figure out how far is each point of triangle ABC located to the right of that line. We're going to have to go the same distance to the left of that line to find the pre-image or the image points. So let's start with point A. All right, point A is right here. All right, and what we're going to do is count how many units it is to the right of x equals 1. So if we start here, 1, 2, 3, 4, 5, 6, 7 units to the right is point A. So we're going to have to go 7 units to the left of that line to get the image of A prime. So 1, 2, 3, 4, 5, 6, 7. Right here is where A prime is going to be located. And that's at the coordinates of negative 6, 3. A prime is at negative 6, 3. Now let's do the same thing with point B. How far is point B to the right of x equals 1? So start on point B and count over. 1, 2, 3, 4, 5, 6 units to get to the line x equals 1. So now we'll go 6 units in the other direction. 1, 2, 3, 4, 5, 6. Right here, that is point B prime. Okay, and so if we go 6 units, or 7 units rather, 1, 2, 3, 4, 5, 6, yeah, I actually did, no, it is 6 units, yep, that's fine. We're gonna have point B prime located at -5, comma, 7, -5, comma, 7. Okay, now we just need point C prime. All right, well, point C is right here. And how far is it to the right of our line x equals 1? 1, 2, 3, 4, 5, 6, 7, 8 units. Now I'll go 8 units more to the left. 1, 2, 3, 4, 5, 6, 7, 8. Right here is point C prime, and it's located at -7, comma, 6. -7, comma, 6. So let's go ahead and connect those points now. And there we have our image of triangle ABC. It's triangle A prime, B prime, C prime. We've reflected over the line x equals 1. If you look at the two triangles that we've created, notice that the triangles are congruent to each other. They're the same size, they're the same shape, all right, because a reflection is a rigid motion. But notice that the orientation isn't the same. The lines aren't going in the same, or the letters rather, aren't going in the same order. If you look at triangle ABC and go clockwise, A, B, C. But if you do the same thing on triangle A prime, B prime, C prime, A prime, C prime, B prime, the letters aren't going in the same direction. So the orientation wasn't preserved, but the two triangles are congruent to each other. In our final example, triangle XYZ has the following coordinates that we are going to graph. All right, X is at 2, -3. 2 units to the right, 3 units down. There's point X. Y is at 4, -5. So 4 units to the right and 5 down. That's point Y. Okay, and that was point X. And point Z is at 6, -3. 6 units to the right of the origin, 3 units down. There's point Z. Let's go ahead and connect those. All right, there is our triangle XYZ. What they want us to do is make triangle X prime, Y prime, Z prime, which is the image of triangle XYZ, when we reflect over the line Y equals 2. And remember, any line that starts out as Y equals is going to be a horizontal line. And so what we're going to do first is draw in the line Y equals 2. All right, the line Y equals 2 is a horizontal line 2 units above the x-axis. And so this is the line of reflection in this example. Any point on that line has a y coordinate of 2. So what we're going to have to do is count and see how far are each point of x, y, z underneath of that line. We're then going to go the same distance above y equals 2 to find the image of x, y, z. So let's start with point x. Point x is right here, and we're going to count up to the line y equals 2. 1, 2, 3, 4, 5 units under. So now let's go 5 units above. 1, 2, 3, 4, 5. Right here is point x prime. All right, and where is x prime? All right, well, x prime has coordinates of 2, comma, 7. 2, comma, 7. Now we need point y prime. So let's find point y. Here it is. Count up to the line y equals 2. 1, 2, 3, 4, 5, 6, 7. Now we'll go 7 units above. 1, 2, 3, 4, 5, 6, 7. Right here is the point y prime. And its coordinates are at 4, comma, 9. 4 to the right of the origin and then up 9. Now we just need point z prime. Point z is found right here. Count up to the line y equals 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 above that line is point z prime. And it has coordinates of 6, comma, 7. 6, comma, 7. So 6 to the right of the origin and then 7 units up. All right, let's go ahead and connect those points now, and we'll be able to see triangle x prime, y prime, z prime. And there's our triangle. Okay, so again, investigating the two triangles, they're the same distance away from the line y equals 2. The triangles are congruent to each other, the same shape, the same size, and the orientation isn't preserved. Okay, if you were to follow the letters going clockwise, x, z, y, x prime, y prime, z prime, the letters aren't in the same order, so the orientation is not preserved.